Hello friends, most welcome to my YouTube channel Maths by Samit Deshmukh. Please subscribe the channel if you are new on my channel and hit the bell icon so that you will get the notification of newly uploaded videos. In this video, we are solving the remaining example from question number 15. So let us see the example number 7th. In this case, we have to prove the following. Means we have to show that the value of left hand side is equals to right hand side. So here we have considered the left hand side. Already we have seen that to solve the example from this exercise, we should have to know the fundamental identities from trigonometry and the interrelation between trigonometric ratios. So well, here we are taking cross multiplication so that we are able to simplify it. Sine into sine will become what? Sine square theta, and 1 plus cos theta into 1 plus cos theta will be 1 plus cos theta whole bracket square. In the denominator, 1 plus cos theta into sin theta will become sin theta into 1 plus cos theta. Just simply we have taken here cross multiplication. So now here we are finding expansion of this bracket using the formula a plus b whole bracket square. And what is the identity? A plus b whole bracket square is equal to a square plus 2ab plus b square. So use this identity to find out expansion of this bracket. So sin square theta, keep it as it is. So here a means a square means 1 plus 2ab means 2 cos theta plus b square means what result we will get? Cos square theta. Keep the denominator as it is, sin theta into 1 plus cos theta. Now if you will observe the numerator very carefully, if we are collecting these two terms, sin square theta and cos square theta, then sin square theta plus cos square theta is equal to 1 according to identity. So first we are collecting these two terms. So sin square theta plus cos square theta. Keep remaining term as it is, 1 plus 2 cos theta, and in the denominator sin theta into 1 plus cos theta. So which is equal to, now in the numerator sin square theta plus cos square theta can be replaced by what? 1. Keep the remaining term as it is. Just I am replacing sin square theta plus cos square theta by 1 plus 2 cos theta, and in the denominator sin theta into 1 plus cos theta, keep it as it is. So which is equals to, now if you will observe the numerator very carefully, 1 plus 1 will be equals to what? 2. And keep 2 cos theta as it is, 2 cos theta as it is. In the denominator sin theta into 1 plus cos theta, keep it as it is. Now if we are taking 2 common, because we will require 2 in our required result, and cosec means what? 1 upon sine, means in the numerator we will require 2 and in the denominator if we will require sine, so that reciprocal of sine will be what? Cosec, to get our required result. Means remaining term we have to cancel here. So which is equal to, if we are taking 2 common from the numerator, so what we will get here? Here remaining term is 1 and here remaining term is what? Cos theta. And in the denominator sin theta into 1 plus cos theta, keep it as it is. Now 1 plus cos theta and 1 plus cos theta from numerator and denominator will get what? Cancel. So keep these 2 as it is. Just simply now we are taking reciprocal of this sine. What is reciprocal of sine? Cosec. So cosec theta. In this way, by considering this left hand side, we have shown that its value is equal to what? Right hand side. Now see the example number 8. In this example, we have to show that tan theta upon sec theta minus 1 is equal to sec theta plus 1 upon tan theta. If you will observe the given example very carefully, term of tan and sec appears in this example. And one identity is also there, which is in terms of what? Tan and sec. What is that identity? Tan square theta can be written as what? Sec square theta minus 1. Applying this identity, easily we are able to show that value of left hand side is equal to right hand side, because if you are taking tan on this side, tan into tan will become what? Tan square theta. And since tan square exists, means we have to solve the example applying what? Identity. So here we are writing the identity. So we have one identity that tan square theta can be written as what? Sec square theta minus 1. Let us try to solve this example applying this identity. Now observe the term very carefully. This tan square, can I write it as tan theta into tan theta? and sec square theta minus 1. Can I consider 1 as 1 square? So now these terms are in the form of a square minus b square. Not necessary to write square here, just try to understand 1 can be written as what? 1 square. Means this side is in the form of a square minus b square. And what are the factors of a square minus b square? A minus b into a plus b. Means here we will get sec theta plus 1 into sec theta minus 1. Means factors of this will be a plus b into what? A minus b. Now if you'll observe very carefully, in this case in the numerator we will require tan theta. So keep this first tan theta as it is. And in the denominator what will require? Sec theta minus 1. Take this sec theta minus on this side. On this side it is multiplied. So if we are using transformation, rules of transformation, on this side it will get divided. So sec theta minus 1. And in the numerator write down remaining term sec theta plus 1 और ये tan theta इधर आके divided हो जाएगा, divided by tan theta. Just by interchanging the term using the rules of transformation, we have got our required result. Same method we are applying in example number 9th also. If you will observe the term here very carefully, so terms are in the form of cot and what? Cosec. And we have one identity that cot square theta can be written as what? Cosec square theta minus 1. So using this identity, let us try to solve the example. Which identity we are applying? Cot square theta is equal to cosec square theta minus 1. Just use the same method. This cot square can be written as cot theta into cot theta, and terms on this side is in the form of a square minus b square. So its factor is a plus b into a minus b. So therefore on this side cot theta, keep it as it is, this term is multiplied, on this side it will get divided, so that is cosec theta minus 1 is equals to, on this side cosec theta plus 1, keep it as it is, divided by what? Cot theta. So in this way we have shown that value of left hand side is equals to what? Right hand side. Now see the example number 10th. In this example, we have to show that multiplication of these two brackets will be equal to tan square A plus sine square A. Now, easily by simplifying this, we are able to get our required result. If you will observe the terms here, it is in the form of A plus B into A minus B. And according to identity, A plus B into A minus B will be equal to A square. What is A here? Sec A. So, A square minus B square. B square means cos square A. So, which is equal to, according to identity, sec square A can be written as what? 1 plus tan square A. Minus, keep it as it is, and cos square A can be written as 1 minus sine square A. Why we are converting it in terms of tan and sine? Because our required result is in terms of tan A and sine A. So now let us simplify it. 1 plus tan square A, keep it as it is. Just simply I am multiplying by minus to both the term in this bracket. Minus into 1 will be minus 1 and minus into minus will become plus. Plus sine square A. So here minus 1 and plus 1 will get cancelled. After cancelling minus 1 and plus 1, remaining terms are tan square A plus sine square A. And if you will observe here, tan square A plus sine square A is our required right hand side. Now see the example number 11th. In this example, we have to prove that 1 plus 3 cosec square theta into cot square theta plus cot theta raised to power 6 is equal to cosec theta raised to power 6. If you will observe the given expression, it is in terms of cosec and cot, and required result is in terms of what? Cosec. Means simplifying it, we have to convert the whole expression in terms of cosec, and cot can be converted in terms of cosec using this result, that cot square theta is equal to cosec square theta minus 1. Applying this identity, we are able to convert cot in terms of what? Cosec. So let us make the use of this identity here. 1 plus 3 cosec theta raised to power 2, keep it as it is, into cot square theta also as it is. Now this cot theta raised to power 6, can I write it as cot square theta raised to power 3? Yes, 3 into 2 is what? 6. This can be written using laws of exponent, or we can say that laws of indices. So which is equal to, now here also cot square is there and here also cot square. So we are able to apply this identity. So 1 plus 3 cosec square theta, keep it as it is, cot square can be replaced by cosec square theta minus 1, plus again this cot square can be replaced by cosec square theta minus 1. Just we have applied this identity here. So which is equal to 1 plus 3 cosec square. Now I am multiplying by 3 cosec square theta in both the terms in this bracket. So 3 into 1 will be 3 and cosec square into cosec square will be equals to cosec theta raised to power 4, and 3 cosec square theta into minus 1 is minus 3 cosec square theta, plus keep it as it is. Now expansion of this bracket can be find out applying the identity. Which identity? That a minus b whole bracket cube will be equal to a cube minus 3a square b plus 3ab square minus b cube. So applying this identity we are able to find out expansion of this bracket. Which identity? Is a minus b whole bracket cube. So according to this identity, what is first term? A cube. A cube means what? Cosec square theta is a and its cube, a cube, minus 3 a square. A square means what? Cosec square theta is our a and this is square of a into b. B is what? 1. Then next term is plus 3a. A means what here? A is nothing but here cosec square theta. Cosec square theta into b square. B means what? 1 square is 1. So here write down 1 square minus b cube. B cube means what? Cube of 1. Just we have applied this identity to find out expansion of this bracket. Remaining part is just simplification part. 1 plus 3 cosec theta raised to power 4, keep it as it is, minus 3 cosec square theta also as it is, plus. So according to laws of exponent, a raised to power m raised to power n can be written as a raised to power m into n. M into n means 2 into 3 will become 6. So cosec theta raised to power 6. Here what we are getting? Minus 3 and square of cosec square will be equals to cosec theta raised to power 4 plus 3 cosec square theta, and lastly minus, keep it as it is, cube of 1 will be equal to 1. So which is equals to, now observe the term here, minus 3 cosec square theta and minus 3 cosec square theta and plus 3 cosec square theta will get cancelled. 3 cosec theta raised to power 4 and minus 3 cosec theta raised to power 4 will also get cancelled. Here this plus 1 and this minus 1 will also get cancelled, and what is the remaining term? Cosec theta raised to power 6, which is nothing but our required right hand side. Now observe the last example from this exercise. Example number 12th. Here we have to show that 1 minus sec theta plus tan theta upon 1 plus sec theta minus tan theta is equal to sec theta plus tan theta minus 1 upon sec theta plus tan theta plus 1. If you will observe the terms in this expression, sec and tan appears, and we have one identity in terms of sec and what? Tan. Using that identity we are solving this example. So we have to make the proper utilize of that identity. Try to understand how to solve this example. Here so we are not solving it in this way. Consider left hand side and try to show that its value is equal to right hand side. Some alternate method we are using here, and we are using the result which we have studied in what? Ratio and proportion. Okay, now try to understand here. So here we have one identity. Which identity? That sec square theta minus tan square theta will be equals to what? 1. Means 1 can be written as what? Sec square theta minus tan square theta. On this side this 1, keep it as it is equal to. Now what are the factor of a square minus b square? Will be equal to a plus b into a minus b. Means sec theta plus tan theta into sec theta minus tan theta. So if you will observe on this side sec theta plus tan theta, such type of term appears. So we are not disturbing to this sec theta plus tan theta. Keep this sec theta plus tan theta as it is. Sec theta plus tan theta as it is. Just shift this term on this side. So 1 upon what result we will get here? Sec theta minus tan theta, isn't it? This term will get divided on this side, and on this side nothing is in the denominator, means 1 is always there in the denominator. Now if you will observe this expression, it is in the form of a upon b is equal to C upon D. If two ratios are equal, we have studied many results which you are getting, which we have studied in which chapter? Ratio and proportion, that componendo, dividendo, alternando, invertinendo, all these results we have studied in your earlier classes. One of the results which we have to use here, that if these two ratios are equal, then it implies that. Now if you will observe this numerator, if you will take the subtraction of these two terms, we will get this result, and in the denominator, if you will take the addition of these two terms, we will get our denominator. Means this ratio, if these two ratios are equal, at that time a minus b upon a plus b will also equal to what? C minus d upon c plus d. Means if these two ratios are equal, then these two ratios are also equal. Just consider one example, 1 by 2 and 2 by 4. What is the ratio of 2 by 4? Is 1 by 2. Means these two ratios are equal. Now consider this as A and this as B. Means A minus B upon A plus B. Let us try to find out value of this left hand side. These two ratios are what? Equal. Just this example I am giving so that easily you are able to understand this result. All such result we have studied in our earlier classes. So well, A minus B means 1 minus 2, 1 minus 2, and a plus b means 1 plus 2 will be equal to minus 1, and in the denominator we are getting 3. Now we are finding value of c minus d upon c plus d. Let us check whether this, what is the value of c minus d upon c plus d. This is c and this is d. So 2 minus 4 upon 2 plus 4 will be equal to minus 2 upon 6. After simplifying it, we will get minus 1 by 3. 2 and 2 from numerator and denominator will get cancelled. And if you will observe that, what is the value of first term? Means first term is minus 1 by 3 and value of second term is also minus 1 by 3. Means we can say that if these ratios are equal, then these ratios are also what? Equal. And this result we are applying here. So here A upon B is equal to C upon D, means expression is in this form. And this says that it can be written as A minus B, means 1 minus sec theta minus tan theta upon A plus B. A plus B means 1 plus sec theta plus tan theta. And on this side, what we will get? C minus D, means subtraction of these two terms. Sec theta plus tan theta minus 1 divided by C plus D, means sec theta plus tan theta plus 1. So this is nothing but reason for it, isn't it? So applying this result, we have got this expression. So therefore, now let us simplify it. One keep it as it is, as one will required here. Minus into sec theta will be minus sec theta, and minus into minus will become plus tan theta. Now in the denominator also, open the bracket, here we will get 1 plus into sec will be plus sec theta, and plus into minus tan theta. Sorry, here minus is there. So minus tan theta will be minus tan theta. And on this side, already we have got the right hand side, so don't disturb to right hand side. Sec theta plus tan theta minus 1 divided by sec theta plus tan theta plus 1, and this is nothing but the result which we have to prove. So in this way, using the result from ratio and proportion, we have shown that value of left hand side is equal to what? Right hand side. Some examples of similar type can also be constructed on second identity, which is the second identity is in terms of sine and cos, and one identity is in terms of what? Cosec and cot. So such type of examples can also be constructed on sine and cos, or on what? Cosec and cot. So in this way, we have completed this exercise.